Hello guys, welcome to EduForest. Today we are going to learn how to determine the area of a sector and length of the arc of a sector. Okay, and today I am going to tell you one simple technique which you can use it to remember the formula for a long period of time. Okay, so let me draw one diagram here. Now look here, this is a circle. Okay, now this is its center. Now guys, just take a point on this circumference here. Okay, now if you join this point, this becomes the radius. Now here I have taken a small stick here. Okay, a small stick here. Let us break this stick from here. Now it is equal to the radius. Okay, now this is the suppose initial position of this stick. Okay, now when these sticks rotate like this, okay, when it makes one complete rotation, okay, then how much angle does it create at the center? It creates 360 degree. Okay, now look here, when this radius makes angle 360 degree at the center, when it makes one complete rotation, how much area does it sweep during that time? Look here, from here to here, how much area it has covered now? This much area. Okay, when it will move to this distance, how much area it will cover? From here to here. Okay, so in this way, when it completes one rotation, how much area does it cover? It is equal to the area of the circle. Now if we take the radius of the circle as r, then what will be its area? Pi r square. Okay, so pi r square. Now look here, when this radius sweeps one complete rotation, makes one complete rotation, it makes 360 degree angle. When it makes 360 degree angle, the area is pi r square. The area covered or swept by this radius is pi r square. Okay, so when the angle is 1 degree, that means when this radius makes 1 degree at the center, means it sweeps only 1 degree, then how much area it will cover? Pi r square by 360. Okay, now suppose from this radius has swept from here to here, from here to here. Okay, so now let us name it. OA is one radius and this is OB, the new radius. Okay, now OA, just make it here x as another point. Now OA XB, this becomes a sector. Okay, now suppose this central angle, the angle made by this arc at the center is suppose theta. Okay, or you can say this, suppose this radius makes an angle theta degree at the center when it moves from here to here. Okay, now when it moves theta degree angle, how much area does it sweeps or does it covers? In 1 degree, this much area is covered. Okay, so in theta degree, it will cover pi r square by 360 degree into theta. Okay, or you can rearrange it like this, theta by 360 into pi r square. Okay, so this is the area of this sector OAXB. Okay, so area of the sector is how much? Theta by 360 into pi r square. Okay, now this is the area of sector. This is the formula you have to remember. Now let us find out the length of the arc of a sector. Now this is a sector. Now here to here, this is the arc of this sector, arc. Okay, now what is the length of this arc? How to determine this one? Look here, the similar technique you have to apply here. How? When this radius complete one rotation, it makes how much angle? 360 degree. When it makes angle 360 degree at the center, what is the length of the arc? Look here. When this radius moves from this position to this position, this is the length of the arc. But when this radius moves from this position to suppose this position, okay, then what will be the length of the arc? From here to here. But when this radius completes one rotation, that means in this way, then what will be the length of the arc? That is equal to the circumference of the circle. So if radius is the r, then circumference is 2 pi r. Okay, 2 pi r. So when the radius complete one rotation or makes 360 degree angle at the center, the length of the arc is 2 pi r. So when 1 degree angle made by the radius means swept by the radius, it will the length of the arc will be 2 pi r by 360. Okay. Similarly, if angle theta is made by this arc, or you can say this radius from this position to this position, okay, when it moves from this position to this position, if the angle is theta, then when the angle is theta degree, then the length of the arc will be 2 pi r by 360 into theta. Because when this radius sweeps 1 degree angle, the length of the arc becomes this one. So when it sweeps theta degree angle at the center, okay, the length of the arc will be 2 pi r by 360 into theta. Okay, so you can write, you can just rearrange it and you can write in this way: theta by 360 into 2 pi r. Okay, so this is the length of the arc. Length of the arc. Okay, or you can simply denote it L. So in this way you can find out the area of a sector and the length of the arc of a sector. Okay, I hope you like this video. If you really like this video, then subscribe this channel and put the bell icon on so that you will get notification when I will post my next video. Till then, goodbye, take care.